Alrighty, so we're going to start talking about combinations of functions. I don't know why they call it this, because honestly, we're just going to be talking about domains the whole time. So we've done stuff like this before. I really like your book because it does do that. It like kind of introduces stuff, and then it gets into it a little bit more, and then it revisits it later, so theoretically you never forget it. Alright, so we're going to start off by talking about the domain of a function. Okay, so let's say we've got f of x is equal to x squared. All right, so do you remember what that graph looks like? So let's see, maybe you remember what it looks like. You say, okay, well, here's my function, or here's my, what's it called, line thingy. Maybe you remember it looks like this. Like that, maybe, yes. All right, now if I asked you for the domain of this function, of course, and if you don't remember what that graph looks like, it's fine, because you do have your graphing calculator. You can always go in here and graph it if you want to. You got your little guy chilling like that. All right, so remember our domain. To get the domain, we do a smush on the x-axis. So if I smush this guy on the x-axis, he's going to go like this. He's going to go all the way to the left. Ah! What just happened? He's going to go all the way to the left and all the way to the right, both directions. So we write that in interval notation by saying it goes all the way to the left, negative infinity, all the way to the right to positive infinity. Neat? All right, so now that you remember what domain means, let's actually do something cool with it. And by cool, I don't mean that. All right. It's cool to me because I'm a dork. All right, let's try another one. So what about function f of x equals the square root of x? So do you remember what that one looks like? You may or may not remember what that one looks like. In case you do, it looks like this. It goes whoosh, like that. And again, if you don't remember what these functions look like, that's fine, because you do have access to your graphing calculator. Find the square root of x and graph it. There we go. All right, so you got that. All right, so now if I'm asking for the domain, remember you're going to squish it down to the x-axis, and by doing so, I'm going to go from here all the way over this way. All right, so to write that in interval notation, we say we go from 0, and we include the point 0, right? Because square root of 0, that's an okay thing to do. Square root of 0 equals 0, in case you're wondering. It goes from 0 all the way out to infinity. Remember, we always put parentheses around the infinities. So that's our domain. And remember what we said about the domain. The whole idea behind the domain is it excludes the points that we don't like. If we go here and we look at our graph, under table, hello, table. Wait a second, table. If we go anywhere past 0, we get errors. Okay, we get errors forever and ever and ever this way. So that means that that those points are not included in our domain because they give us errors. Okay, so now the question is though, how could we figure this out? Without graphing it. Okay, we're not really going to get into problems that we couldn't solve by graphing today, but we will later, so you have to learn these skills now. So don't just rely on your graphing calculator. Use it as check. Use it to check, but don't just necessarily rely on it to do these problems, because you might miss something later. All right, so how do we figure this out without graphing? Well, we say, okay, well, I have a square root sign. What's the deal with square root signs? What do I not want to do with square roots? And the thing with square roots is I don't want to take the square root of a negative. I don't like taking square roots of negative numbers, right? We don't like taking square roots of negative numbers. You can say, I only like taking square roots. Oops, I'm not going to write all that out. I only like taking square roots when the stuff under the square root sign is positive, right? Actually, positive. Actually, instead of saying positive, what we really mean is we're okay with it, fix that, is if it is greater than or equal to 0, right? Because 0 is okay. Anything greater than 0 is okay, as long as it's not negative, and that's what we don't want. So what we really want to say is we would take this, whatever is underneath the square root sign, that's our x, so that's the same thing. We take our x, we say this x has to be greater than or equal to 0. All right? So if we think about what that looks like on a graph, on a number line, if x has to be greater than or equal to 0, remember we graphed it by doing this, greater than or equal to 0, and then to write an interval notation, 0 to infinity. Now if you'll look, this is the same thing. So this way, over here on the right, we did this algebraically, and on the left, we solved it using graphing. So I guess what I want you to recognize is we can solve this both ways. I want you to see that there's a connection between what we're doing with the domain and what we're going to be doing algebraically with what we did with the graphing before. All right? Good? Good. Like you can answer me. I just assume you know what I'm talking about. If you don't, definitely let me know. Let's try this one. It's fun to talk to myself. F of x equals 1 over x plus 3. Now, I'm willing to bet that you're probably not wanting to graph that for memory. So let's graph this on the calculator. Well, let's see, go in here. So my y equals, and I had 1 divided by x plus 3. All right, make sure you get your parentheses in there like I had them. If you don't have your parentheses like that, it's not going to be pretty. All right, so we're going to go in here and going to graph. And our graph looks like that. Good? And what did I do last time that was super awesome? I grabbed it and I pulled it over here. Cool. All right, so I've got my graph. Let me go get it. I pull it off to the side. There we go. Look, see, I don't even need these dumb old lines. Oops. Apparently I do. They don't want to go away. All right. So I've got my little graph here and my graphing calculator. And you'll see right here, something's going on. I'm going to make a little funny line. You'll see that right here at x equals -3, this line up here, it gets really, really close, but never actually touches it. This line down here, I can't draw perfectly on my thingy, but this line here gets really, really close and never actually touches it. Okay? This line here, this line is called an asymptote. All right, it's called an asymptote. It means you get really, really close, but never touch the line. Okay, and actually I am going to go ahead and redraw this by myself so that I can emphasize to you what I'm trying to do. So over here at -3, I've got my asymptote. And I've got a graph that goes like this, and a graph that goes like this, that forever and ever, and that forever and ever. So now if I want to look at my domain, what's my domain? You could probably do it on the one above. I just want to be able to draw bulkier lines. So if I smushed it on the x-axis, I would start out here at -infinity. I go all the way. But would I ever actually get to x equals -3? And no, remember the answer is no. We get really, really close, but we never touch. That means there's a hole right here. X equals -3. Even this guy up here, he doesn't touch -3 either. And then we go off this way forever and ever and ever. Like that. Got it? So now if I want to describe my domain, I start all the way. Remember, I read my domain from left to right. That's the worst arrow ever. I'm going to write my domain from left to right. So I start off here at negative infinity, and I go all the way to negative 3. I have a hole at negative 3, so I don't put a bracket. This isn't an equal. It's almost there, but not quite. I'm going to do the union symbol. That's how we combine multiple intervals. So union, and then from negative 3 out to infinity. All right. So the domain for this function is negative infinity to negative 3, and then 3 to positive infinity. Does that make a reasonable amount of sense? All right. Now the question is now, how could I figure this out without graphing? I can't spell. So think about this. How could I figure this out without actually graphing it? Theories? Ideas? Well, what do we hate to do? What do we hate to divide by? We hate to divide by what? We hate to divide by 0, right? We hate to divide by 0. So what we want to do is we want to exclude, and it's a critical word, we want to exclude any points where the denominator is 0, right? All right, so now what we're going to do is we want to exclude any points. Now we're just looking at the denominator. All right, we're just looking at the denominator. So I'm going to write in big words, big letters, exclude. I want to exclude the points where x plus 3 is 0. Okay? Any point where x plus 3 is 0. So what I really want to do is I want to exclude x equals negative 3. So if I draw my number line, 0, negative 3, to exclude negative 3, I draw a circle around it, and I include everything else. Right? To exclude negative 3. And now I write this in interval notation. I go from negative infinity to negative 3, union, negative 3 to infinity. Now you'll look, see we've got the same answer, and we got it 2 different ways. This way over here on the left, again, we did this graphically. And over here on the right, we did algebraically. So you'll see there's definitely a connection between, you're going to get the same answer either way, but I just want you to know that you can get it 2 different ways. But we're really going to try to focus on doing this algebraically and just use the graphing to confirm that what we did was right, because later on that skill is going to become even more important.